Okay, so get this. Our listeners sent in some research about AI writing code, but then proving that that code is actually correct.
Yeah.
I gotta say, that's a combo I haven't seen before.
It's pretty wild.
Yeah, so we're diving into a research paper called Proving the Coding Interview, a benchmark for formally verified code generation.
That's the one.
And just the title alone, I'm already intrigued.
Yeah.
So set the stage for us. What's the big idea they're tackling here?
Well, it all starts with this question, can we really trust AI to write mission-critical code?
Okay.
The kind of software that's running things like self-driving cars or medical devices.
Right.
And we know that large language models, or LLMs, they're getting pretty good at just churning out code these days. They can even solve, those tricky coding interview problems that tech companies love to throw at you.
The ones that are designed to make you sweat a little bit?
Exactly.
Even if you've been coding for a while.
Yeah, but there's a difference between passing a coding interview and writing software that, controls a car.
Right. Yeah, for sure. The stakes are a little bit higher.
Exactly. And that's where the limitations of just traditional testing become clear.
Okay.
You can run thousands of tests, but you can't possibly test for every single scenario.
You can't think of everything.
And that's where formal verification aims to come in.
Okay.
It uses mathematical proofs to guarantee that code behaves exactly as intended.
So it's not just hoping for the best. It's we know for sure.
It's a mathematical guarantee.
That this isn't going to go haywire.
Exactly.
Okay, I like it.
No matter what.
All right, so this paper introduces something called FVAPPS.
Yeah.
Which already sounds pretty technical.
It is a bit of a mouthful.
Yeah, can you break that down for us?
Sure. FVAPPS stands for Formally Verified Automated Programming Progress Standards.
Okay.
It's essentially a benchmark, a way to measure how well AI is doing at generating code that can be mathematically proven correct. And the really cool thing about FVAPPS is its size. We're talking over 4,700 Lean 4 files.
Wow.
Which makes it the largest formal verification benchmark ever created.
Okay, hold on. Back up for a sec. Why is that a big deal?
Sure.
Does size really matter when it comes to benchmarks?
It actually does. Think of it like this. The bigger the benchmark, the more challenging the problems.
Okay.
The more we can really push the limits of AI and see what it's capable of.
You're really putting it through its paces.
Yeah.
Okay.
So FVAPPS is kind of like this proving ground for cutting-edge AI, really paving the way for software that we can truly rely on.
I mean, that's a good point. If you're going to have a benchmark, might as well make it a good one.
Exactly.
So, okay, you've got this massive benchmark.
Yeah.
How did they even go about building this thing?
Right. It was a pretty massive undertaking.
Yeah.
They actually used a really interesting pipeline, leveraging another AI, Claude Sonnet, to help. Yeah. So they started with existing coding problems and solutions from a benchmark called APPS.
Okay.
And then they used Claude to generate these superpowered tests called property-based tests.
Property-based tests. Okay. I'm already lost. Those sound way more intense than your average,
Right.
unit test or something.
They are, imagine like a unit test on steroids.
Okay.
Instead of just checking very specific inputs and outputs, property-based tests check the code's behavior across a huge range of possible inputs.
Okay, so it's not just you put in a 2, it gives you a 4.
Right. You're testing all sorts of crazy edge cases.
It's like a whole spectrum.
Exactly.
To really make sure it's going to...
It's much more thorough. You're much more likely to catch potential problems that way.
Okay, I like it. So they've got these super rigorous tests.
Yeah.
What's the next step in the pipeline?
So this is where it gets really interesting. They used Claude again.
Oh, wow.
But this time, to translate those property-based tests into formal theorem statements written in Lean, which is a language specifically designed for mathematical proofs.
I see.
It's like they're translating the logic of those tests into the language of mathematics.
Got it.
So instead of just saying, this code should do X, they're saying we can mathematically prove this code will always do X.
Okay, so they're not messing around.
No.
It's like a hardcore math proof time.
Exactly.
All right, so what then?
Well, then they took the original Python code solutions, translated them into Lean as well.
Okay.
And then they ran the whole thing through the Lean Prover.
And Lean Prover, that's like the judge?
It's like a program that checks if the mathematical proofs actually hold up.
I feel like I'm sensing a but coming here.
You're right to be sensing that.
Okay. It can't be that easy, can it?
Not quite. Yeah, there were definitely some hurdles along the way.
Okay.
So they had to create this thing called a scaffolding loop.
A scaffolding loop. Okay.
It sounds complicated, but essentially they had to repeatedly refine the AI's output
Okay.
until it met their standards for quality,
Yeah. So it wasn't just like one and done.
Right. It was an iterative process.
They had to kind of teach the AI as they went.
Yeah, there was definitely some back and forth.
Okay. Interesting.
They also used a tool called Plausible to filter out theorem statements that were likely to be false.
So kind of like a quality control step?
Exactly, just to make sure they were working with good data.
Okay. I mean, it sounds like they were basically teaching this AI
Yeah.
to think like a mathematician, which...
So easy feat.
Yeah, no kidding. So, okay, big question here.
Yeah.
Did it work?
Right.
Are we on the verge of AI being able to handle all of our formal verification needs?
Well, to answer that, they ran some experiments.
Yeah, okay.
They used both Claude Sonnet and Google's Gemini Pro.
So, the big players.
Yeah, two of the leading AI systems out there on a subset of 101 problems from FVAPPS.
Yeah.
And the results were, well, a bit of a mixed bag.
Okay, walk me through it. What did they find?
Both AIs could solve a decent chunk of the coding problems themselves. But when it came to the proofs, they really struggled.
So the AI is good at, writing the code.
Yeah, they can follow instructions.
But not necessarily understanding the why behind it.
Exactly.
Okay.
Turns out formal verification requires a very specific kind of thinking, one that's much more abstract and focused on logic and reasoning.
Yeah, it's not just connect the dots.
No, it's more like understand the underlying principles.
Got it.
To illustrate this, how tough these proofs can be, they even had a human expert try to solve one.
Okay.
And it took them 10 hours.
10 hours for one problem.
Yeah, that's how challenging this stuff can be.
Okay, so that really highlights the challenge here.
It does.
That AI might be able to write the code, but not necessarily understand.
The deeper why behind it.
Like you said, the logic, the reasoning.
Yeah, which is crucial for formal verification.
Okay, so where does that leave us?
Right.
Is this whole AI-powered formal verification thing just a pipe dream?
Not at all, I think. Even though AI isn't ready to replace human mathematicians just yet,
Yeah.
FVAPPS has given us a really valuable tool for measuring progress in this field.
Okay.
It's like this benchmark that's going to push researchers
Right.
develop new techniques, new training methods that will help AI tackle these more complex proofs.
So it's a challenge to the AI community.
Exactly.
All right, smarty pants, let's see what you can really do.
Exactly. And this challenge has spurred some really interesting research directions.
Okay, tell me more.
Well, for example, some researchers are exploring ways to make code itself more proof-friendly.
Okay.
If the code is structured in a certain way, it becomes much easier to apply those formal verification techniques.
So it's if you organize your tools in your workshop.
Yeah, great analogy.
Everything has a place. It's much easier to find what you need, get the job done.
Exactly.
Makes sense.
Another really exciting direction is the development of these hybrid systems where AI and human experts work together.
Oh, interesting.
On formal verification. So imagine a tool where the AI suggests different proof strategies.
Okay.
Or it identifies potential flaws in your logic. It's basically assisting human mathematicians in the process.
So kind of a partnership?
Yeah, leveraging the strengths of both AI and human intelligence.
Okay, I like that. That's cool. But let's be realistic here for a second.
Yeah.
Formal verification is complex. It's time-consuming.
It can be.
Isn't that a major roadblock to wider adoption?
It's a valid concern, and you're right.
Especially in industries where things move really fast.
Yeah, for now, formal verification is mostly used in those high-stakes industries.
Right.
Like aerospace, autonomous vehicles, where safety and reliability are absolutely paramount.
Yeah, you don't want any surprises there.
But the research community is actively working on making formal verification more scalable, more efficient.
Okay.
Imagine tools that can automatically verify huge portions of code, freeing up those human experts to focus on the really critical parts.
That would be a game changer.
It would.
For sure.
And as those tools improve, become more user-friendly,
Yeah.
we can expect to see formal verification being applied in areas that we might not even be thinking of today.
Okay, what? Give me some examples.
Think about things like e-commerce platforms,
Okay.
online banking systems,
Right.
even social media networks.
Interesting.
The potential applications are vast.
So formal verification could become a standard part of the software development process.
I believe so.
Not just like a specialized niche thing.
Yeah, and AI will continue to evolve and play a key role in making that vision a reality.
This is so cool. This whole conversation has really shifted my perspective on AI. It's
Yeah.
not just about replacing human programmers.
Right.
It's about augmenting our abilities
Mm-hmm.
and creating a future where software is not just more powerful, but also more reliable,
Yeah.
more trustworthy.
Exactly, and as this technology matures,
Yeah.
it's going to raise some really important questions about how we develop and interact with software.
Like what, for example?
Well, for example, think about like real-world examples.
Okay, yeah.
Where's this technology actually being used today?
Right, right.
One of the most prominent examples is in the automotive industry,
Okay.
specifically with self-driving cars.
Makes sense.
Companies like Tesla and Waymo, they're using formal verification techniques to make sure that their autonomous driving systems are operating safely and predictably.
Yeah, you would hope so.
Right.
Like, that seems like an area where you really, really don't want
High stakes,
yeah, any surprises.
for sure.
So how does formal verification actually fit into that whole development process?
It's used in various stages. For instance, AI can be used to generate like all these diverse driving scenarios,
Oh.
from, routine lane changes to really complex situations
Okay.
with pedestrians and other vehicles and all sorts of things.
Oh, wow.
And then those scenarios are fed into a formal verification system
Okay.
that mathematically checks if the car's software responds correctly in each case.
So it's like they have a virtual proving ground
Exactly.
where they can just run through
Test it out.
millions of different situations
just saw that.
before it ever hits the real road.
And this is where the power of formal verification really shines.
Okay.
It can uncover potential issues that might be missed by those traditional testing methods, just driving around.
Right. Yeah.
So you can be much more confident that the software is really robust and reliable.
Yeah, in a wide range of situations.
Yeah, in those real-world conditions.
Okay, so it sounds like AI and formal verification.
Powerful combo.
Yeah, for developing autonomous vehicles, are there other industries where this approach is kind of making waves?
Absolutely. The aerospace industry is another big one.
Okay, yeah, that makes sense.
Think about the software controlling an airplane or a spacecraft. Like, the margin for error there is incredibly small.
Infinitesimally small, yeah.
Exactly.
So, yeah, no room for mistakes.
All right, so companies like Airbus and SpaceX rely heavily on formal verification
Mm-hmm.
to guarantee that their flight control systems are correct and safe.
And it's not just about, like, preventing software bugs or glitches, right?
It's about making sure those systems can handle unexpected events,
Right.
equipment failures.
Like, if something goes wrong,
Right.
it's not just going to fall out of the sky.
Exactly. You need to be able to respond appropriately.
Right.
And formal verification allows engineers to actually mathematically prove
Wow.
that that software will respond appropriately, even in the face of unforeseen circumstances.
Okay, that makes me feel a lot better about my next flight.
Exactly.
But it's not just these kind of life or death industries, is it?
No, not at all.
Where else is this tech kind of finding a foothold?
Well, we're seeing a surge of interest in the financial sector,
Okay.
particularly in areas like high-frequency trading and blockchain technology.
Okay, yeah, so like very different applications.
Very different, but still high stakes.
Right.
Think about the potential fallout from a software glitch in a trading algorithm
Right. Billions.
or a security flaw in a cryptocurrency platform.
Yeah, you're talking about massive sums of money.
Potentially even impacting global markets.
Right.
So how do we mitigate these risks?
Yeah, how do we make sure that doesn't happen?
Well, financial institutions are starting to use formal verification
Okay.
to provide this higher level of assurance that their software is correct, secure, and reliable.
Okay.
This can involve mathematically proving the absence of vulnerabilities in a system,
Okay.
or ensuring that a trading algorithm executes trades according to very specific rules
Right.
and risk parameters.
So you're not going to end up accidentally bankrupting a country or something.
Exactly.
It sounds like this is kind of becoming a must-have
Yeah, it's gaining traction.
for any organization dealing with, sensitive data.
High-value transactions.
Yeah, high value anything.
Yeah, for sure.
And it seems like AI is playing a pretty key role here in making this tech more accessible.
Yeah, more efficient.
Yeah.
AI-powered tools can automate many of the complex tasks
Yeah.
involved in formal verification.
Okay.
So that makes it much more feasible for companies to actually adopt these methods.
So you're not spending years and years
Exactly.
trying to prove every single line of code.
It can help speed things up significantly
Okay.
and ultimately lead to systems that are not only more efficient, but also much more secure and robust.
This has been a really cool deep dive.
Yeah.
We started off with this question of, can we trust AI to write code?
Right.
And I think it's clear that while AI alone might not be the answer,
Yeah.
the combination of AI and formal verification is pretty powerful.
It's a game changer.
Yeah, for sure.
It's already making a significant impact across a ton of industries.
Yeah.
And I think we're really just scratching the surface of its potential here.
Okay.
As the technology continues to evolve, we can expect to see even broader adoption, more innovation.
Yeah, more applications.
Exactly, in the years to come.
I'm excited to see where it goes from here. This is really, really interesting stuff.
Me too. It's a really fascinating field.
So I want to thank you for joining us on this deep dive.
It was my pleasure.
And I want to thank all of you out there listening for sending in this research.
Yeah, keep those suggestions coming.
And for tuning in and learning along with us. We'll see you next time.
See you next time.
For another deep dive into the cutting edge of tech and knowledge.
Until then.